Okay, guys, it's me again. I'm out for my training today. Yeah, I'm still sick, but I'd be here if I could. I'm going to show you guys what I want you to do after you go home tonight. I think it's really going to help us start the lesson off too, so I'm going to show you what to do. I've talked to you guys about ClassZone.com before, and I want to show you guys a little video of exactly how to get there. So I'm opening my Firefox page, and here's the address bar. You can do the Google search over here, but I would say to go to the address bar and just put ClassZone.com, and there it is. And since I've already been to the website before, it knows what book we have, but you guys have probably not been there yet. So what you need to do is you need to come down here to this part where it says select your subject, because you probably won't see this part right here. You'll say select your subject, and it's math, of course, and then you're in middle school or high school? Yeah, middle school. And the next part, you can click California, that's your state, and then it'll say find your book. So here we go. Our book is the one with the girls playing volleyball. You click it, and here we are. Okay, I've talked to you guys about the at-home tutor, and there's some pretty good stuff on there too. And there's also some really good stuff right here at the video tutor with practice. But the part I really want to get you guys to is the animations. Okay, so you're going to click animations. There's these two little alien dudes down here, okay? You can find it pretty easily. Click animations, and then here's the part where you might get lost, but I'm going to explain how to do it so you won't. On the top right here, top left says chapters 1 through 3. Well, we're in chapter 5, so you click chapters 4 through 6. Oops. Click chapters 4 through 6. And you're going to go right here where it says chapter 5, algebra tiles. Let me drag this over so it's in the full window. And I'm going to cut to a smaller screen now. Okay, to save some space, I went ahead and made my screen a little smaller so we can focus on this little part right here. This is where we should be now. And it should say algebra tiles. And on the very top of your window, it should say algebra or animated math. So it says, welcome to the interactive extension for this lesson. Click on the button to begin. Click on the button below to begin. To return to the lesson at any time, close this browser window. So start activity. And here we go. So it says, use the algebra tiles to model the equation below. When you have finished, click check the answer. So what we have here, you guys, is we have a little representation of what we're doing today. And what we're doing today is we're simplifying equations. We're not simplifying expressions, we're simplifying equations. And that's one of our key terms today. And the one thing you guys can tell, one thing you can check for in an equation is, guess what right there? The equal sign. Okay, it's really easy to remember because equation equal. Every single equation has an equal sign. Alright, this is the real fun part of algebra, you guys, because we actually get to solve stuff now. Forget all the simplification and all that mumbo jumbo. We're getting to the real deal, the real algebra business where we get to find what in the heck is the answer. So let's try and find it out. What we have here is what we call algebra tiles. And algebra tiles help us to see the math, which is always a good thing because a lot of us don't like to think about it in our heads. So what we have here is the variable tile. And this variable tile is kind of like a bag, like a Mary Poppins bag. I don't know if you guys have seen Mary Poppins. It's an old school Disney movie, I think. I think it's actually the very first non-cartoon movie I ever owned. Way back when, I remember I was kind of upset that my parents, or that my grandma got it for me because I only liked cartoons way back when, you know? Funny. Actually a really good movie. But Mary Poppins had this bag that could fit anything she wanted in. It was like the size of, like, you know, a small duffel bag you would take on the airport if you're gonna go for like a weekend or something like that. And she could fit like a whole, like a super tall lamp inside it. She could fit, you know, a bucket of nails. Or she could fit anything in it. It was like this magical bag. And so that's kind of what this tile is right here. This is like a bag that has unlimited space inside. But instead of putting lamps and buckets of nails and anything else we want, we're going to put the ones in there, okay? But we're not going to know how many there are. So here what we have is we're gonna actually get to drag these tiles. You can see we can move it. I don't know if you can hear that jingle jangle. That's my dog, Lucy. Maybe I'll show her to you guys at the end. We're gonna get to drag these tiles to the left side and the right side of the equation. Okay, and I'm gonna talk about the sides a lot too, you guys. A little side note here. I'll talk about the left side and the right side of the equation. And I always like to think of the equation as the middle point. So This says 1 plus x equals 9. And so if we want to do this exactly right, we would take our 1's. You just pick any of these 1's and you can drag it straight over to represent the 1. And then we have to represent the x. And do we know how many the x is yet? Well, maybe some of us can see what the problem is going to be, but officially we don't know what the answer is going to be yet. So this says 1 plus x, or x plus 1. The order does not matter because we have the commutative property of addition. We can flip-flop those all day long. Alright, and now 1 plus x equals 9. So now it's time to drag down 9 1's over here. 2, 3, 4, 5, 6, 7, 8, and 9. Okay, so let's check to see if our answer is correct. Hey, it says we're doing a good job. I better get it right. Correct. Click continue to continue. Well, let's continue. So all we did right now, you guys, we just modeled the verbal or the algebraic expression with tiles. All we did was change the language, kind of. So let's continue. All right, next, we're going to solve the equation. Here's the good stuff. You must get the x tile by itself on one side to solve. This is something we're going to talk about a lot, you guys. The way we're going to solve is we're going to get this x all by itself. The way I've liked to explain it in the past is the x is a grumpy, stinky, angry, no patience hermit. And a hermit, somebody who lives by themselves, usually up on top of a mountain or in some jungle somewhere away from all kinds of other people, because he hates them. The x is a hermit. And this hermit does not want to be next to this 1. It wants to be on the other side of the equation from this 1. So let's try and help him get rid of the 1. Now, another thing I like to think of here, guys, is this equation is kind of like a balance. Can you guys imagine a balance like where they used to weigh, like maybe if you were at a market and you wanted to know how much 5 pounds of potatoes was? Well, the guy selling you the potatoes, this is back before they had the spring ones like they have at Vaughn's. They'd have a 5-pound weight. Maybe it was a rock that they knew was 5 pounds or a piece of metal, and they would weigh it against your potatoes. And they'd have 2 plates on opposite sides of a little triangle or some kind of hook that was hanging there, and they would weigh the potatoes. And if the balances were even, then you had the right amount of weight. So here we like to think of our equation like a balance. You can imagine that there's like a triangle right here, and this blue stuff is going to equal this blue stuff. It's going to be in balance. So I wonder what would happen if we took away something, though. Could we click that and get rid of it? What's going to happen? I would say this side's going to be lighter, isn't it? And then it's not going to be equal. So if we want to take away something from this side, we have to do the exact same thing from this side. Click. Okay, now because we got rid of the same amount on both sides, this thing should still be equal. Let's check and see if it's true. Awesome, it is. Correct. So now we figured out. We changed it up a little bit. Now we can have x all by himself. Remember that grumpy hermit? He's all by himself now. X equals 1, 2, 3, 4, 5, 6, 7, 8. All right, I think we may have solved it. Let's try and find out what's going on. Okay, now enter your answer in the box below. When you finish, check the answer. Okay, so I think we just did this step. We counted and we found out x equals 1, 2, 3, 4, 5, 6, 7, 8. Let's check it to see if it's correct. X equals 8. Ding, 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 we got it correct. Awesome, we just solved this equation. Good job, guys. This is your very first one. Let's check another one just to make sure we have it down. And then I'm going to go back to my paper and ask you guys to do a few with me, then together, and then all by yourselves. Okay, I'm going to go a little faster for this one because we've already seen it one time. So 2 plus x equals 7. Let's model that with our algebra tiles. Here we go. X, we have one x over here, and we have 2 1's tiles, and then 7. 1, 2, 3, 4, 5, 6, and there's my 7th one. Let's check to see if we did it right. Good job, we did. Next. Now we're going to try and solve the equation. Now, I don't know if you guys noticed earlier, but something happened. This says 2 plus x, or it could also say x plus 2. What did we do earlier? We clicked the little tiles. It says click the tiles, select the tiles you wish to remove. Okay, so when we check them, it's like we got rid of them, right? In other words, we could say we subtracted these tiles from both sides. Okay, the equal amount on both sides. Very interesting. Let's check our answer here. Awesome, we did it right. So correct. This is a really important point, you guys. To make the x by itself, the trick is you need to use the opposite operation for this 2 right there. You need to use the opposite operation of the number you're trying to get rid of. Okay, so if this 2 is being added, we need to subtract by 2. And I'll show you what it looks like on paper in a minute. Alright, awesome. And then our final answer, x equals 1, 2, 3, 4, 5. Alright, cool. Now if this was a balance, it'd still be in balance. The size would be level, and we'd be a happy customer buying the 5 pounds of potatoes or whatever else we would want to buy. Okay, I think we can do new problems for a while. I'm not sure how many it really has here, but I want you guys to go on here to classzone.com and follow the steps again. And that way you guys can have a little practice with the algebra tiles that you're on your own, and it'll tell you if your answer is right or not. And it's kind of a cool way to play with this thing. And tell you what, if you guys can prove to me that you went on classzone.com and you played with the algebra tiles, then I will give you 10 points extra credit on a homework assignment, okay? So it's like you can undo or redo with that pretty much. It's pretty significant, okay? So I hope you guys will get a chance to do it. If you don't have a chance, like your computer's broken or you don't have internet at home, try and get to a neighbor's house if you can, or a friend's house, whatever. But if you don't, I will help you out before school on Thursday if you really, really want the extra credit. Okay, but I'm not going to take anything after that. You have to really want it and get there before the bell rings, okay? And I'm not talking like 2 minutes before the bell rings. I'm talking like at least 10 minutes before the bell rings on Thursday when I get back. Okay, next part's coming up real quick. Okay, I hope you guys like the math animation. It should be really helpful in helping you guys visualize what we're going to be doing today. So again, today's 5.3. Solving equations using addition and subtraction. Now I'm going to ask you guys to get your books out in a minute, but not yet. I want you guys just to watch me. Don't even copy this down yet, okay? I want you just to watch me. Because I'm going to show you guys how to solve an equation. I'm kind of getting ahead of myself. Let's go back and take a look. Alright, here we have an equation. And like I talked about before, we know we have an equation because of our equal sign, okay? So I want you guys to tell your neighbor right now that all equations have an equal sign. Go ahead and do that right now. All equations have an equal sign. Ready, set, go. Okay. So all equations have an equal sign. That's the difference between an equation and an expression. So up until today, we only worked with expressions. And there's still pretty much, well, we still are working with expressions. We have an expression on the left side of the equation and on the right side of the equation. The left side says a plus 9, and that's an expression. 16 by itself is actually an expression as well. So what we're doing is we're testing to see if these two expressions equal each other. Actually, we're not even testing right now. We're just going to find out what number we need for a to make these two equal each other. Okay, we're going to try and figure out what number equals a to make this equation true, okay? To make sure that both sides are equal. All right. So what we're trying to look for is going to be the next term that we're going to use today is called the solution of an equation. And the solution of an equation, just the answer. Okay, solution means answer, and the solution of this equation is going to be what a equals. You'll find it by we're going to subtract in a minute. I'll tell you about that. And then when you subtract, you're going to find out what a equals all by itself. When you find it out, you've finished the problem by finding the solution of an equation. All right. Next is equivalent equations. I'm going to show you what an equivalent equation is in just a minute. And then we're also going to use the inverse operation, but we'll get to that in a minute too, okay? All right, so I want you guys to imagine this expression, or this equation, excuse me. I want you to imagine it like a balance beam like I talked about earlier in the other video. the beginning of today, here's what I'm talking about. Let me draw you a little picture. Here's a little balance point, and here are the scales, okay? We're weighing both sides against each other to see if they're equal. Okay, and if they are, they're balanced. Well, let me tell you right now, these both left and right sides, the left side of the equation and the right side of the equation, they're balanced. They are balanced. Now, I want you guys to imagine what would happen if we took away, just like in the animation earlier, what would happen if we took away 9 from both sides? What's going to happen? Is the equation still going to be balanced? I want you to ask your neighbor, okay, at least one person and your partner and you need to figure out, if you subtracted 9 from both sides, would your equation still be balanced? Go ahead and take a minute to ask your partner that, and if you don't know, if you or your partner don't know, then ask somebody in front or behind you or in a row right next to you, okay? Take about 10 seconds for that. Ready, go. Okay, you guys should have had enough time to talk about that real quick. And the answer is yes. If we took away 9 from both sides, we would still have a balanced equation. If it was on a scale, the scale would still be level, telling us we have equal amounts on both sides. So let's do this in the math way, okay? I'm going to move down a little bit. I'm going to start over. A plus 9 equals 16. Make sure my 9 is good. And it looks like a 9 instead of an A. Okay? A plus 9 equals 16. Now check out what we're going to do here. We're going to subtract. What I like to think of it like, I like to think of it as making a gigantic subtraction problem on both sides. Okay? We're going to subtract 9 here. And we're also going to subtract 9 right there. Okay, you guys should still just be watching. I shouldn't see anybody, or I shouldn't have anybody copying down yet, because I'm doing first. Okay, so A plus 9 is our expression on the left side, and we're going to subtract 9 from that. So what happens when you add 9 and then you subtract 9? What happens there? Think about that for a second. You guys should see it turning to 0, right? Because 9 minus 9 is just 0. So what you end up with here is A plus 0 equals, now what? 16 minus 9. What's that going to be? And that's 7. Okay, now do I need to put A plus 0? Isn't it kind of like too much? Can I just put A equals 7? Yeah, I can, okay? So I'm going to just put A equals 7. And it seems to me, without even really trying, we just kind of solved the problem. Okay, we did. We found out that A, all by itself, remember how A is a hermit and wants to be all by itself? A equals 7. And so we found out what number, 7, can be used back in the original problem to give us a true and balanced statement here. So let's try it out. If we did 7 plus 9, we get what? That's right, we get 16. And that's what we had over here all to begin with. And so we checked our answer, and it is true, and we know we've done a good job. Okay, now this brings in two things. There are other two terms we need to learn about. The first one is equivalent equations. Now here's the deal, guys. A plus 9 equals 16 is equivalent. Equivalent means kind of the same. It means the same, but it looks a little bit different. But it has the same value. A plus 9 equals 16 is an equivalent equation to this guy right here. They're equivalent equations because they came from the same problem and they equal the same thing. They came from the same balance scale. Okay? And the other thing I want to point your guys' attention to is the inverse operations. Where's my green pen? Oh, here it is. The inverse operation was this, these two guys right here. Okay? We started out with plus 9. And then we had to do the opposite, or the inverse. Okay, those words mean the same thing. Opposite and inverse. So, plus 9, how do we do the opposite of that? Well, we subtract 9. And you guys, it's so important that you do it to both sides. Okay? I want you to turn to your partner right now and tell your partner, you have to do the inverse operation to both sides. I'm going to repeat it. You have to do the inverse operation to both sides. Tell them right now, please. Okay. If you guys don't follow that rule, you will get the wrong answer every single time. I guarantee it. Okay? So I want you, it's even worth repeating one more time. Tell a person in front or behind you, the inverse operation always happens on both sides. Tell them, it's so important. Tell them again right now. Okay, I think you guys had enough. It's time to move on to the next example, okay? Okay, so here's the next example I want us to go over. This problem I want you guys to do with me. Okay, you're going to copy down in your notes at the same time as I'm doing things, okay? So I'll go plenty slow so you guys can copy each of my steps, and then we'll get it done together, and then we'll move on to group work. Okay, x plus 8 equals negative 15. So I see an equal sign, which means we have an equation. We have an equation here. Okay, give you guys just a second more to copy this down. Make sure it's all in your notes, ready to go. Okay, so I want you guys to repeat this next thing with me. I'm going to repeat it twice, and then you guys are going to repeat it. Okay? Alright, to solve this equation, we are going to use the inverse operation of addition. To solve this equation, we're going to use the inverse operation of addition. Okay, what that means is we have x plus 8. We're trying to get the variable all by itself. Remember the grumpy old hermit who lives up on the hill by himself and he hates neighbors. And the 8 just moved in and he is fed up. So he's going to go and say, okay, I'm going to use the inverse operation of addition on you and I'm going to get rid of you, you stupid 8. And he says, poof, I'm going to do it right now. And so he goes down and he says, okay, I've got a minus 8. And he can't just do it to one side of the equation, he has to do it to both sides.
You must do it to both sides.
So the 8 can end up somewhere else. And he goes here and says minus 8 to you, right side of the equation. And we're almost done. So I like to make a little line there so you can see it's kind of like a subtraction problem. And we have 8 minus 8. And that obviously gives us 0. Now, do you guys need to write down 0 here? Yeah, probably not. You can if you really, really want to. But I think we can see that it ends up with nothing. And sometimes, or most of the time, we don't even need to write down that there's nothing there. We just leave it alone, leave it blank. So what's really left over here? What's left over is the x. Okay, the x is going to come down all by itself and happy. And the x is going to equal this side over here. Now we haven't done the step yet, so what is it? Negative 15 minus 8. Now you guys, what I see here is I see a problem like this. Subtraction is the same thing as adding a negative, isn't it? Or adding the opposite. And when you add negative 8 and negative 15 together, they have the same sign, which means you just add the numbers and keep the signs. Add the numbers and keep the signs. So negative 15 plus 8, last time I checked, that's 23. And we're going to keep the negative sign, like I said. Okay, so if we've done all of our steps correctly, we should have a final solution here. X equals negative 23. And then it's time to check our answer. So this should be the solution of our equation. Hopefully it's going to go ding, 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 and flash the lights and tell us we get the jackpot. Well, let's test it out. And we test it out by plugging our answer, negative 23, into the original problem to see if we get negative 15. So let's try it out. Negative 23 plus 8 equals negative 15, hopefully. Okay, if this works out, if it says this side equals 15 and that side says 15, then we know we did a good job, and I'm pretty sure we did. So negative 23 plus 8. A lot of you guys can do it in your head. If you can't, you can know they have different signs. And when you have different signs, it's like subtraction, right? So 23 minus 8 is... 23 minus 8 is 15. Okay, here's our first set of partner examples. Partner 2, you are going to start things off, and you are going to explain, explain, explain. Partner 1 is going to listen, 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 watch, 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 and then finally copy, copy, copy. And of course you're going to check to make sure there are no mistakes being made. Then you're going to go to Partner 1's problem. Now I'm going to explain Partner 1 in just a minute. Actually, I'll do it now. It looks a little different, doesn't it? Our variables on the right side, our constant term it came first, and that might freak you guys out a little bit, but guess what? Same old story. You're just going to use the opposite operation. What is this number right here? Is it positive or is it negative 3? Okay, I think it's positive 3. So how are you going to get rid of positive 3? You're going to subtract 3. Okay, I already gave you a major hint there, and make sure you do it to how many sides? Just one? One side? No, both sides, okay? Both sides are going to have the inverse operation of whatever number is next to your variable. Okay, Mr. Terry, will you please pause the video and check the clock behind you for about, let's give them about 3 minutes for these two problems, maybe 4 if they're still being productive. All right, thank you so much, sir. Pause now. Okay, folks, you guys probably had a good time doing these two problems. They should have been really easy, and you guys should be masters of this just about by now, okay? So, here we go. What's bugging the x? What's bugging the x? This 10 is bugging the x. We need to subtract it by using the inverse operation, and there we go. Make sure we do it to both sides, minus 10, and we get x equals, let's put our subtraction signs so we know what we're doing. X equals 6. If you guys checked it, you would have found it's correct. So good job, x equals 6. Partner 1, excuse me. You guys should have subtracted 3 from both sides. And when you did this, you should have found out these guys cancel. Your y is left over. The equal sign drops down just to where it was. And then negative 10 minus 3 is the same thing as adding negative 3, isn't it? Yes, it is. This equals negative 13. So y equals negative 13. If you want to try it out and plug it in, 3 plus negative 13 equals negative 10. Is that true? Yeah, it is. We check our answer and we get the same exact thing on both sides of the equation. So good job, people. I hope all of you guys got this one correct, these two correct. And I'm guessing you did because you guys are all plenty smart, okay? Next one's coming up. Okay, next problem. I want you guys to take a quick look at this problem and this equation and see if you can tell what's different about this one than the other ones. Just take a look quietly, please. You don't need to blurt it out. Alright. Yeah, okay, a lot of you guys probably spotted that we have, subtraction. Okay, well, we're going to use the same basic rule. We're going to use the inverse operation. Now, if the inverse operation of addition was subtraction, what's the inverse operation of subtraction? Alright, you guys are sharp. It is indeed addition. Okay, so we're going to be adding 15 to both sides. So with this one, I want you guys to go ahead and do with me. Let's go ahead and skip the just watching part because you guys already got the hang of this. This is old news, okay? I'll give you a second to copy this down. Alright, about 3, 2, 1, and you should be done by now. Okay, x minus 15 equals 9. We're going to add 15. We're going to do the opposite operation of this part that's attached to the x on both sides of the equation. So, plus 15 on both sides, plus 15. Make your little sign right there. Okay, negative 15 plus 15, poof, they cancel out. Our x is happy, it's all by itself. The equal sign comes straight down. And then 9 plus 15 is 24. Alright, and we solved our equation. One simple step. Okay, two little math steps combined into one step. So x equals 24. Okay, let's go ahead and make you guys' partner problems right now.
Okay, guys, we're coming to the end of the lesson. We have partner 1, you're doing y minus 23 equals 77. Partner 2, you're doing the opposite one, not opposite, but the opposite side. It says negative 3 equals f minus 9. Don't be confused, just follow the rules. The f wants to be by itself. We're going to be doing opposite operations wherever we can, and solving and checking our answer by plugging what we think is the solution back into the original problem. Ready? Go ahead and give you guys Same thing as last time, 3 minutes if you guys need it. If you need more, then you can take 4 minutes if Mr. Terry thinks you need that, okay? Go ahead and pause the video now and resume in just a minute.
Okay. You guys have had enough time now. Let's go ahead and add. Let's do the opposite operation. So we have y minus 23. What's the opposite operation? Addition. Okay, we're going to add 23. It's the same number here every time, you guys. Same number every time. We don't ever change that because we're trying to get rid of it. We're trying to make it poof. Okay, we do it to both sides.
Both sides.
And let's go ahead and add them up and see what we get. Here we get a poof. So y equals 77 plus 23. Oh, what do you know? 100. How perfect. All right, partner 2, you guys should have been adding 9 to both sides because adding 9 is the opposite or the inverse operation to subtracting 9. F minus 9. Okay, so negative 9 plus 9, those cancel out. Poof. F is left over. Equal sign drops down. So negative 3 plus 9, well, they have opposite signs, so you can subtract. 9 minus 3 is 6. The 9's bigger, so it keeps the sign. So our answer is 6. F equals 6. Now, I want to tell you guys one thing here. The proper way to give your answer is just to flip it. Okay, the proper way to give your answer is just to say, oh yeah, F equals 6. Is this wrong? No, not wrong at all. But this is the proper way. Okay, it's like keep your elbows off the table. Why? And that's because it's a rule. Okay, same thing here. All right, good job. Okay, guys, that's the end of our lesson. Now I'm in my baby's room, but it's full of like a bunch of baby stuff because my wife's had 2 baby showers now, and so we've got like a Babies R Us in here. You know what I mean? It's like Toys R Us, but for babies. So we basically got one of those in our house right now. Anyways, today's lesson should have gone well. The sound was fixed today, so that shouldn't be a problem. And you guys should remember all the key terms. An equation, we can always tell what's an equation because it has an equal sign. Equivalent expressions or equivalent equations are basically 2 equations that are the same, but they've had stuff subtracted or added to it, but they're still balanced. And the solution to an equation, what was that one? That was just the answer. Okay, so we should have been able to go through and know to solve these equations with addition or subtraction. We just need to use the, think about it for a second, we need to use what new technique? The opposite operation. The opposite operation. And what thing wants to be by itself? What thing is really grumpy and is a hermit and wants to live up on the mountainside all by itself? Okay, yeah, it's the variable. The variable is that it's kind of a dumb little story, but I hope it makes it stick in your guys' brains. I told you guys I'd show you my dog. And so here she is. Lucy! Lucy, come here! Look in here. Come here. Hey, hi, come here. Alright, here's Lucy. Say hi to Lucy. Good girl. She got a lot of hair. She's a miniature schnauzer. And she does not know how to look at the camera. She's a good girl. Alright. See you guys on tomorrow.
Both sides.